In this video, I'm going to be making calculations about how we can calculate effective resistance in series and in parallel connection. Right away, let's say if I have two resistors. Now, for these resistors to be in series, they have to be connected to each other with no point where current is divided into the other resistor. Now let's give an instance that at this point let's say I'm having my first resistor. Let's say this is R1, and I'm having my second resistor. This is R2, right? Now as current flows through R1 and R2, now let's say this is I, right? The current that flows through R1 is the same current that flows through R2, but the PD, let's say the PDs are different, right? So out of that, if I have, let's say, from this point to this point, right, that this is V1, right? And then let me change this, that I have this is V1. I have V1, and then at this point I'm going to have V2, right? And this point right here. Now the PD in each resistor is different, but the current through these resistors is the same, right? So out of that, if you look at this, that for me to get the effective resistance, I know that current is the same, but from Ohm's law, we know that V is equals to IR, right? But since current is the same, current is the same in that the current through R1 and R2 is the same, but the PDs are different, right? So out of that, let's say I know that, let's say for total, this is like total PD. Let's say if I add V1 plus V2, give me the total PD, right? Which would be V. So out of that, but I know that V1 from Ohm's law, V is equals to IR, right? So that means that if I have, this will be IR1 plus IR2. This will be equals to the total current, right? And then times the total resistance, right? Total resistance across the circuit. So if you look at this, that I'm having here, since current is the same, if I factorize out the current, R1 plus R2 will be equals to, I'm going to be having here IRT, right? Now if the current cancels out, I'm going to have R1 plus R2, which would be equals to RT, and therefore this is how I can get effective resistance in series connection. Now the same way, if I have, let's say, one that's connected in parallel, right? Resistors connected in parallel. Now let's consider this, that I have a point where current is flowing in. Now let's say I have a resistor at this point. At this point, I'm also having a resistor, right? Now current, as current comes in, this is the total current, it divides, right? Here we shall be having I1, and at this point current will flow through this, and this will be I2. But then as current reaches this point again, right, we shall have the total current, which is as a result of I1 plus I2, right? So it's let's say the current was split from this point, of which I can refer to this as a node, right? Then let's say and then joined from here. Let's say I1 plus I2 to form I again. So if we take this as our resistor R1 and this is R2, right? Now we know that let's say current through R2 and R1 are very different, but then the PD of R1 and R2 are the same, right? But then I know from Ohm's law that V is equals to IR, right? Now, since PD is the same, now I need, let's say, to get this like in terms of, since current is different. So if you look at this, V all over R will be equals to the current. But then I know that I'm having I1 plus I2 will give me the total current. If you look at this, I'm having I to be equals to I1 plus I2, right? So, but I know that I is equals to V over R. That means that V all over R, but this will be the total resistance, right? So this will be equals to, I'm going to have V all over R1 plus V all over R2. Now, since PD is the same, right? So I know that out of that, I can cancel this out. This. So I'm going to be having 1 all over RT will be equals to, which RT in this case, we are taking it as the effective resistance. And therefore, this will be equals to 1 over R1 plus 1 over R2, right? So this is when, let's say, we are in parallel connection. Furthermore, if you look at this, now this is a voltage divider, right? And let's say in series connection, we form what we call a voltage divider. Then in parallel connection, we form what we call a current divider, of which we are going to see how to get current through, let's say, another resistor that is in parallel with the other one, or the one that is in series with another resistor. Now let's try to bring it out. If you look at this, that let's consider in series connection, that now current is flowing through, and this is R1 and this is R2, right? Now current is flowing through R1 and R2, but we know that current through R1 and R2 is the same. So here, but the PDs are different, right? So the PD through R1 is V1, and the PD through R2 will be V2. So since the PDs are different, but I know that for total PD I'll have V1 plus V2. No, so now in case I want to get the other one, I have to make one the subject. That means that V minus V1 equals to V2. Now, since current through R1 and R2 is the same, what I'm going to say that I1 is equals to I2. The current through resistor 1 is equals to the current through resistor 2. So out of that, but I know that from Ohm's law, that I itself, right? I is equals to V all over R is equals to I, right? So what I'm going to do here, considering this, since these are the same, I'm going to say that V1 all over R1 will be equals to V2 all over R2. Also, I'm going to have my V1, of which here I say that I was having V2 equals to V minus V1. So in the same case, so I'm having V, and so let's make out the substitution. So that means that V1 all over R1 equals to V2, which will be V minus V1 all over R2, right? Now, by cross multiplication, we know that here we are going to get something of this sort, right? We are going to have V1 R2 equals to R1 V minus R1 V1, right? So out of that, but what we need here, let's see, if you look at this, we're going to bring this side. We are going to have V1 R2, right, plus R1 V1 equals to R1 V, right? So that means that if we factorize out V1, that V1 will be equals to R2 plus R1, right? So this will be equals to R1 V. Then if you look at this here, that means that V1 is actually equals to R1 multiplied by the total voltage over total resistance plus R1, right? Now this is how, let's say, like let's say a series connection works like that. For it, it is a voltage divider, right? Now let's also look at the parallel connection, right? How it acts like a current divider. And what are the changes? We realize that here, let's say V1 corresponds to R1 all over R2 plus R1, let's say multiplied by the total voltage, right? Or the PD. Now, in the same case, let's see how this works in parallel connection. That I'm having something of this sort, right? I'm having my parallel connection. Let's say we're having our parallel connection that I previously drew here. So this is the point, right? Let's say current flows in. Now that current divides into I1 and I2. So this is R1, R2, and then joins again I1 plus I2 form I again, right? Now out of that, this is the total I. Now we know that in parallel connection, PD across the resistors is the same, but current is different, right? So we know that I will be equals to I1 plus I2. Yes? Then let's make one of them the subject. That I minus I1 equals to I2. Right? So that means that if I'm having this, but I know that V1 is equals to V2, right? But then I know that V is equals to IR. That means that I1 R1 equals to I2 R2. Awesome. So that means that this is I2. That means that I1 R1 equals to I2, of which to be I2 minus I1, right? Close this, R2. Awesome. So now let me extend this here, that okay, that then if I have I1 R1 will be equals to, we would have R2 I minus R2 I1, right? Now, having got that, I need to bring this to this side. That means I1 R1 plus R2 I1 will be equals to R2 I, right? So that means that if I factorize out I1, that I1 into R1 plus R2 will be equals to R2 I, right? This will be I. So that means that I1 equals to R2 all over R1 plus R2 multiplied by the total current, right? But now if you look at this, there's a difference that here the current through resistor 1 corresponds to R2 divided by R1 plus R2 times the total current in another part of the circuit, right? But then when we're in series and we're using, let's say, a voltage divider, that V1 was corresponding to R1 over R2 plus R1 multiplied by the total circuit voltage, right? So this is like the basic theory of how, let's say, we can get the effective resistance, how we can get current through, let's say, one of the resistors. We can get the PD across one of the resistors,